Welcome to another installment of the vBrownBag APAC podcast. Today's episode is going to be a bit of an overview of Hyper-V 2012 R2. The main premise for this episode is to give you a bit of a primer for our upcoming series on the certification 74-409 from Microsoft, which covers server virtualization and System Center. So I'll be your host and presenter, Brett Johnson, and I can be reached on Twitter at BrettJohnson008. So before we get into it, just a few quick notes to go over. If you want to contact anyone from vBrownBag or see what we're up to, there's a couple of different Twitter handles, depending on where you're located, that you can use. So we've got the @vBrownBag one which will cover APAC and US, the LATAM one, which is for our Spanish vBrownBag, and for the Middle East, Europe, there's the EMEA one. Now, we also use the hashtag vBrownBag as well in most of our posts, so if you search on that, you can see a lot of stuff that we're up to. If you'd like to watch live, we've got a few different time slots as listed there. Now, let's get into it. So, Hyper-V. It's a Type 1 hypervisor from Microsoft, meaning it abstracts the hardware completely away to provide a virtualized environment to be able to put VMs on. Now, it was introduced in Server 2008, and since then it's undergone a lot of improvements, and thankfully for the large part on that. Now, it comes with the operating system, so there's no fee to put it on there. It's free, and there is also an option to download a Windows Server Hyper-V, which is just a server core with Hyper-V, and you don't do anything else on it. So it's pretty easy to check out and sort of start playing with if you feel like it. Now, to use Hyper-V, just like a lot of other hypervisors, you do require a 64-bit processor, and you need to have the virtualization technology turned on. So for Intel, that will be Intel VT or AMD V. Now, most modern processors will have this already ready to go. Sometimes you may need to enable it on the motherboard, and if you try to install Hyper-V without that enabled, you will get an error to say you can't do it, that a requirement is missing, and that's usually your first step. As far as looking at things such as memory and hard disk space, that's all just dependent on what you're trying to do. So what your VMs require. So if you've got a VM that requires 24 gig of RAM, you're going to want to have at least 24, probably a couple of extra gig for the underlying hypervisor as well. And same with hard drive space. If it needs 300 gig of hard drive space, you need 300 gig of hard drive space available. Now, there have been a lot of improvements through each step of Windows Server. So from 2008 to R2, and obviously most recently 2012 R2 has continued to bring new features and improvements. So depending on the version of Windows Server or when you get to client, desktop OS you're using will depend heavily on what you can actually do. Now, Microsoft have been doing a big push for quite a while now for for PowerShell. And one of the benefits with that is it means that Hyper-V has a native PowerShell support. Everything you can do through the interface, you can do through command line, and some things you can do in command line only. If you've been putting off learning PowerShell, it's definitely a good reason to start. It's quite a nice scripting language to use, makes sense, and it's not too bad once you get the hang of it. So there's two types of Hyper-V. There's the client Hyper-V, which comes with the desktop edition. So your Windows 7s, your Windows 8s, 10s. It's included as part of the operating system. There's no extra downloads for it. And if you want to enable it, it's just through Control Panel, your Programs and Features, and Windows Features. Install it, restart, you're good to go. It'll give you a good feel for Hyper-V. You can do a few things, probably most of the things you could do on the server one, but there are limitations. Things such as replication aren't going to work. But if you've got a laptop that you want to test it out on and you don't have access to a server OS, it's definitely a way to get used to it, get your head around the terminology, what you can do, and just sort of pique your interest. You can also run the PowerShell commands against it. The server Hyper-V is the one we'll be talking about today. It's got all the features, comes on the Windows Server OS from 2008 onwards. As I mentioned, the features depend on the operating system, so you can't patch Hyper-V on 2008 to do everything 2012 R2 Hyper-V does. You need to have that actual underlying operating system. It's installed either through the Server Manager as a role or a feature, or through PowerShell with the install Windows feature command, and we will go over that shortly. You can run it on Server Core or as the full graphical installation of Windows Server OS. Now, managing Hyper-V is quite easy and is really easily done remotely. So if with your Hyper-V servers, they're intended to only be a Hyper-V server, so there is very little reason to run the full desktop OS on that actual server. But if you do choose to install the full desktop, you can use the built-in Hyper-V Management Console, which will come when you install the role. From your desktop, you can use the download RSAT, so the Remote Server Administrator tools, which will include the graphical console. It'll also include all the PowerShell commandlets for Hyper-V, so that things such as get VM. On top of that, you may find that you need to enable the firewall rule on the actual Hyper-V server using the enable net firewall rule, or possibly remote management by running winrm space QC through command prompt or PowerShell. And PowerShell can be used to manage Hyper-V. Now, there's two main ways to do it with PowerShell. If you've got a lot to run against it, you may want to enter a PowerShell session using the enter-ps session command, which we'll show you, or a lot of commands also support putting in -computer name, which will tell it which computer to run the command against. Now, when you create a VM, you need to select the generation, and depending on the way your infrastructure is set up, it depends on how much consideration you want to give this. If you have Hyper-V hosts that are not all 2012, you may want to go for a Gen 1 server. You may want to select Gen 1. The reason for this is Gen 2 is only available on 2012 R2 hosts. So if you have a VM running that and it's Gen 2, you can't send it to a Gen 1 or to, say, a 2012 server. It won't be able to run that. Also, once you select a generation, that's it. That's what the VM's going to run. It's going to run Gen 1 or Gen 2. You can't jump between the two. Both will support 32 and 64-bit guess. There are a lot more features available in Gen 2, such as Secure Boot and EFI. If you wanted to do a Pixie boot on Gen 1, you do need to use a legacy network adapter. You can't use the standard. So you'd either need to add it, do the boot, remove it, whatever you feel like there. With Gen 2, it is supported on the standard network card. So, with networking, you have what's called a virtual switch. So this is a switch you set up for hypervisor, for Hyper-V, and that determines the connectivity levels your VMs have. So we've got three options there. The first one is the private. A VM on a private one can only talk to other VMs on a private network, on the same private switch. So if you have multiple private switches, they can't talk to each other. It's very isolated. One of the things you could use this for example, is if you have a couple of servers you want to restore from a DR backup, just to make sure they'll boot, talk to each other, and get along to help test your backup plan. You definitely don't want them talking to your environment. And if you don't have full dedicated infrastructure for it, if they go on a private switch, they'll talk to each other. It'll be great. They'll probably complain they don't have internet access. That's not part of that. As long as that's not part of the test, you're pretty good. So set that up, test it. It's very isolated. Internal one allows you to talk to the VM host. So this is your host server that's running Hyper-V. So if it needs to have any sort of networking between those two, such as files, then you can do internal. It can also be useful if you want a test lab where it's partially isolated off, might be the way to go. External is probably going to be the more common one you'll see, where the VMs can now contact a physical network adapter or a team of NICs. So if you've set up NIC teaming for redundancy, you can attach an external switch to that, and that would be the recommended way to do it, because you don't want to have, say, half a dozen servers relying on one physical NIC. Now, once they're connected to an external, as the name suggests, they get external access, so they can access your full network, or however you've set it up, they'll get internet access, that sort of stuff. Now, there's two different types of disks you can use for Hyper-V. The first one is the original, the VHD. Now, it's got a 2 terabyte limit. It'll work all the way from Server 2008 onwards. Now, if you want to do anything, say, enlarge the disk, you're going to have to shut that VM down. It's limited in its capacity for what you can do online, and for the most part, what you got to do, any maintenance you want to do on it, you got to take it offline, which can be quite a big drawback in a production environment. You don't want to have to sit there, shut down a file server, and then put it back on just because a heap of people downloaded the new iOS update and you've got redirected folders happening. Now, VHDX is the newer one. It's got a massively increased limit, so it's got a 64 terabyte limit. It also uses a 4K block size, so generally speaking, that'll give you a bit better performance. It uses metadata, so its entire structure is different. So by doing that, it helps prevent against data corruption if you've lost any power on your server. So if the UPS has failed or whatever, the host is just completely shut down unexpectedly, it's going to help prevent corruption against that. Now, it gives you a few nicer features, such as you're able to resize it online. So you can, with all those iOS updates that everyone's done, you can then just update it and off you go. Now, you can convert from VHD to VHDX, and you can go back, but it's an offline process. So the servers have to be shut down, you do the conversion, and then remap the drive. Because it's got a different file extension, you need to select the drive and go from there. Now, storage pools. Well, storage pools is generally a bit easier to describe when you see it. Essentially, what you do is what it is you present a bunch of drives, so just a bunch of drives or a JBOD to your Hyper-V server, and they go into a pool called a primordial pool. From there, you can create other pools. If you're used to traditional storage, think of the pools a bit like LUNs. So you've got your standard LUN or your JBOD, and from that you create your LUNs, and from that you can then put data onto it. In this case, we create a pool, and then we create a virtual disk that sits on that pool. It's integrated with features, and some of these we won't go over, such as the failover clustering for HA, and there is also tiering as well. So if you've got SSDs and some spinning Rust, you can run tiering across those to help get better performance. And you can also create virtual disks, and within those virtual disks you've got a few options for resiliency. So you've got your mirroring, your standard one-to-one mirror. Parity, which is a lot like RAID 5 in that it uses parity between the drives, and striping, which, well, isn't a resiliency option, but it does give you a bit better performance and will stripe that virtual disk. Now, VM memory, we'll go over a little bit, but there is a lot of detail on VM memory options, and if you're doing it in production, getting your VM memory right can have a dramatic impact on your performance. More to the point, getting it wrong can have a dramatic impact on performance. So you've got two main memory options within Hyper-V. The first one is the startup memory. So startup is the minimum amount that VM needs to boot. For example, if I've got a server and it's got a 2 gig RAM, requirement won't boot with anything less than 2 gig of RAM. That's what I want my startup memory to be. So I'm going to turn it on. It's going to get straight out of the gate 2 gig of RAM. That'll allow it to boot, get in there, and then if nothing else is selected, that's its memory. Yeah, it's recommended your startup memory is as small as you can go. Your dynamic memory is a range. So you might set a minimum of 64 megabytes. You can go really small if you want to. And a maximum 64 terabytes if you feel like it. So it needs to be supported by the guest OS. If the guest operating system doesn't detect those changes, you're going to have a bit of a bad time. So you need to make sure that the operating systems you're doing it on will support this change and this fluctuation in memory. As it asks for more memory, it can be provided more memory. So one of the examples of you could use this for is if you've got a server during the day, it does its processes, uses a couple of gig of RAM, no big deal, but it's got to do some big batching at night. Or you've got a server that may just do batching at night. And it needs to use a lot of memory for this process. You don't want to be using it all day because then you've got to buy more memory or you've got to work out how it's going to fit with everything else. So you may just want it to, during the day when everything else is nice and idle, to grab as much as it can. So it might grab 256 gig of RAM and just get its batching out, get it done nice and fast. Then during the day it can peter back down to 12 gig of RAM. So that's sort of where you can use dynamic memory to your advantage. It also allows overcommitment. If you've got during the day when everything's running, it might use quite a bit in this example, and then everything else dies down, but you've got another server now that can take up all that now unused memory. So you can overcommit that memory depending on your workflows. There is a waiting option. So you can say, how important is this VM? How much memory or how much precedence does it have over another one that might need some memory? So then if you get times contention, the one that's got a higher weight is going to be able to sit there and you say, oh, this is mine, and the other ones just have to sit back and wait their turn, basically. And there's a buffer as well. So this is, if there's a big spike really quickly, it doesn't need to wait to get that memory allocated for the Hyper-V server to say, oh yes, you need some, here you go. It's got that buffer. Now, a buffer isn't guaranteed. So as contention builds in your environment, that you might have a 20% buffer in set. It may only have 5% actually allocated to it. So I've included a TechNet article there. Instead of typing it in, if you just Google Hyper-V memory options, I'm sure you'll find that same article and be good to go. One of the other points I wanted to touch on before we sort of go into the lab area is integration services. So integration services are built into a few of the Windows operating systems from Server 2012 onwards or Windows 7 onwards, and these allow features such as time sync, guest shutdown, and that. So with time sync, what it will do is it will sync the time of your guest operating system, so your VM's operating system, to the VM host. If you're doing that, you really want to make sure that your VM host is getting time from an accurate source, whether it's internal or something like ntp.org. Guest shutdown allows you to cleanly shut down your VM from the management console or through PowerShell, instead of actually going into the VM, going shut down, yes, this is my reason, okay, it's shutting down. If you don't have guest shutdown, your only option is to turn off the VM, which really isn't a good idea because it's no longer clean. Heartbeat monitoring is where the Hyper-V server will try to detect a heartbeat from your VM or from your guest to help determine if that operating system is locked up. If it's locked up, it shouldn't be getting a heartbeat, and you'll be able to get an alert or take appropriate action. Now, the backup one is quite a nice feature. This is for when you use a backup that it works from a VM level, and what it will do is allow what's called application-aware backups. So with this is for things such as Exchange, where it can go in there. It will be able to take a granular snapshot you'll be able to do granular restores of Exchange. It'll be able to truncate the logs to free up disk space after it's done, and everything will time up nicely with the event with all your logging. So if you have to do a restore one, you can do it, say, an individual mail item or a mailbox, and some of these features obviously depend on your backup software. But it will also allow you, excuse me, it'll also allow if you do a restore for everything to already be in right time sync. I've had instances before where I haven't had application-aware backups and restoring Exchange just came up with corrupted mailboxes because the log files didn't match up and really just made that job take longer than it actually needed to. So, we have our little test environment here. I've got a domain controller and just sitting there at the moment. I'll remove this from my testing. We're going to use the domain controller to test a couple of PowerShell scripts. So everything I show you through the actual interface will also be done again through PowerShell. Might just make that resolution a little bigger if I can hit the right options. See if this will let me go a bit bigger. So this is the full desktop install of 2012 R2, and this is the core 2012 R2, just to show managing server core and how it's realistically not different to if I was to manage the full desktop. So if we wanted to install Hyper-V on this server, it's a matter of going to adding roles and features, role-based installation. If you were managing other servers, you could do the install to them now, but we're not managing any on this, and we're only going to do the install locally to this computer. So we just tick the Hyper-V option, and you'll see we get a couple of other options here. For the most part, we're going to ignore these, and we're going to do these through the management console. So these are the network switches we can set up. We can select network controllers, or if we had a team, we could have a team of network cards in there. We're not going to do that. We're going to leave all that empty. Now, live migrations allows you to send VMs from one server to another. And it's important to understand the authentication protocols here. So the CRED SSP is you've got to initiate the migration from the server that it's currently sitting on. So if I had a VM sitting on HV1 and I want to send it to HV2, I have to log into HV1 and do it. I can't use something such as RSAT because just the way the credentials are set up here. So the better option is to use Kerberos, and that will allow me to use things RSAT, PowerShell, initiate it essentially from wherever. Now, we're not going to worry about live migrations in this one. It's something, if you want to have a look at, set up your own lab. It is also something that will be covered in our certification series. Okay. Default stores, you're going to want to set these for where you sit your VM somewhere redundant or shared. Obviously, this is a lab, so we'll just put them in the default location because, nothing really running on it. Now, as it's a type 1 hypervisor, it does require a restart. It's going to enable Hyper-V when you start up. So when it'll go through, this will automatically restart. Now, I'm sure we've all seen a server restart before, so we don't need to watch that. Now, installing it via PowerShell. The command is install Windows feature, and then we put the computer name. So this is the target computer we wanted to install. So if you're doing this through the interface, this is the part where you select another server. So I want to do it to HV2, which is my server core, sitting right here. Hyper-V is the name of the feature. Yeah. With the include management tools, well, generally you can use this for the actual management console. Include management tools also installs the PowerShell commandlets. If you don't do this, you can't do anything via PowerShell. So, and considering we're running server core, it's pretty important. Now, the restart parameter at the end. This is the same as that last tick box, which automatically restarted the server. If I don't hit that, or if I don't put that in there, it's not going to restart. If I want it to restart immediately, we leave that there, and off it goes. HV1's all up and running, and 2 will be restarting in a moment. So just remember, in production, using the administrator account's a bit of a no-no. Also, using passwords such as password 1 is usually seen as a bad practice. So we'll get a notification here that it's all done. And if we want to, alright, so there is also a deployment template which should give us some information about how the deployment went and what we were doing. So they're always good to read through. It will tell you what happened. So we've got Hyper-V here. We can see on the side now this is a Hyper-V server and give us some information specific to it. If we had other servers added and they had Hyper-V roles, we would see them down here. So for example, if I wanted to manage HV2, once it's added, it will show up there. It may just take a moment. There we go. HV2. Look at that. Now, if we were to manage locally, this is going to look the same as if we were to manage remotely. It'll automatically connect to itself. We can see, I already created some VMs before when I was testing all this. So, first step I like to do is creating the virtual switch. Now, these are the options. Initially, we need to set what type of switch it is. Now, this isn't set in stone. We can change the switches on the fly. So, we'll give it a very original name and apply that. So, if we want it to be an external switch, we need to select which network card or NIC team we're going to use. Now, you can see there, allow management operating system to share this card. So this is if we want that network card presented also to be used by that by the host. Otherwise, we could have one dedicated just for hosting. I guess the best way to think of this is the one that's only for a host could be considered a management, or run it out of band as well if you wanted to do that sort of thing. Now you can also VLAN ID. So if you want a trunk coming in, you can always have those options too. So I could have multiple switches on that NIC, and we can run a VLAN ID. Now, internal or private, as we mentioned before, so if we want this completely isolated, we'd go private or internal. For what we're doing, we'll just leave it as private. We're not actually going to install any VM operating systems. We're just having a bit of a look. So we've got our switch up and running, just making sure I did that. So we want to create a VM. So by default, it will store the VMs where we set the default locations to be. If we want to store it elsewhere, we've got the tick box and we can go from there. Now, this is where we set the generation of the VM. And once again, we've got the warning. Once the virtual machine's been created, you can't change its generation. It's done. So we'll go Gen 2. How much memory? This is the startup memory. I'll leave that as it is, but this is where we can set the startup memory. Now here's our vSwitch. If I had multiple virtual switches, I'd see each one there that it can use. We definitely don't want to set 126 gig hard drive. I don't have that much space on this little test machine. So we can connect to an existing hard drive if we want to. If we've got this VM installed and we've had to tear it down but we've kept the hard drive, we can attach it to another one and just boot it, attach one later, or create one as we're going. So we're just going to create one as we go. Now, with the operating installs, the general way you would do it is through attaching an ISO file. Just browse to them and select it, and away you go. You can install it from network-based installation, so using, say, something such as Pixie, or just select to use later. And we're done. Now create it. Ah, yes. We already have a virtual hard disk in place. Let's just attach a new one, or attach an existing. Alright, and that's it. From here, if we want to take a snapshot of, in Microsoft terms, a checkpoint, we can. So checkpoints are useful if you're doing an update where you can go through and roll it back if there's an error. If something fails, roll it back, you're good to go. Quicker than usually restoring from a full backup. Now, if we want to have a look at the VM and use it through an interface, we right click on it and go connect. From here we can power it on. And we're not going to get much happening here because we don't have any operating installed. We don't have any media attached to it either. So we'll just wait for this to boot up, and just so you can have a bit of a look at its boot process. Oh, you can see it's booted. It has no OS, so it's failed for a SCSI device. It's now looking for a Pixie boot. So up here with our options, we've got turn off, which is the equivalent of pulling the power cable out. I'll press and hold the power button. Or shut down, which is the nicer option where it will give the guest operating system the notice that it wants to shut down. At the top, we'll start it up again, so we'll see a little bit. We've got a little bit of information here about how much memory it's got assigned and using, processor usage, and its uptime. That's always just a nice quick area. And if you're running a task against it, that's what the status will just show. Throughout the settings, we've got a few different options. We can add network adapters, fiber channel adapters. I don't have any fiber channel adapters, so I can't show that. Firmware, where we can set our boot order, so we don't need to try to get into a BIOS or anything like that. We can just change which order we want to do. We can also enable secure boot. Memory. So this is where we can set our dynamic memory if we wanted to and set a more realistic maximum. And we've got the minimum 32, there you go. If you need extra processors, and there's some reservations, again, things I'm not really going into this option at the moment. And if you want to add new hard drives, click on the SCSI controller, we can add a drive, we can attach, we can go browse to attach one, or we can create a new one. Now, when you create options through hard drives through this option, you do get a few more options as well. So the fixed size is, if I wanted to create a 10 gig hard drive, it's going to drop a 10 gig file on whatever storage I have. A dynamically expanding one, they start off at about 4 megabytes, and then as you add data, they grow. So it allows you to over provision your storage capacity, which is great for resource usage. On the other hand, it does add a little bit of management overhead because you really don't want your storage to actually run out if it hasn't been monitored. Differencing it's an interesting one. It's, if you've come from a VMware world, think of it as a linked clone. So you've got your parent hard drive, it's a read-only copy, and then it stays intact. Nothing happens really to it except read. And then from there, it creates a child disk or a delta disk, which is where all the writes go. Now, the child has to be the same format as the parent, so VHD or VHDX. The rest is basically just what do you want to call it, where do you want to store it, and you can create blanks. So this is where we can set our size, and you can also copy contents. Also, you can copy the contents of a virtual hard disk. So, for example, cloning, you might want to use it in that aspect. We've got our integration services down here, so we can enable and disable. All the ones here are just your defaults. So these are all on by default. You may want to say turn off data exchange, because it's just, you just do. When you set checkpoints, they automatically go to wherever your default location is. You may want to change this to a drive that has more capacity. So for the actual interface stuff, that's mostly what I wanted to cover. We'll come back here and we'll have a look at storage pools shortly. I think I'll need to delete the one on this server to show you how to create them. So let's do this all via command line. So these are the steps I went through on HV1 that we can go through on HV2. So first of all, we want to connect to it, because we want to run all the commands against one server. We might as well just connect to it with a PS session, and there we go. We can see we've got HV2. Now we're going to set a variable VM path, which is going to be where we're going to put certain objects. Now, I believe that I already have a folder sitting there. Yes, I do, VMs. So that already exists there. We're just going to use that path as a path for a couple of things. So if we wanted to create a switch, we would use the new switch, or new VM switch, and we set it to a private, and that's the name. So if we were to go through graphical management, we will see now we have a test private switch. So if I was to remove it, and come back in, we'll see it's there again. Now, we want to create a virtual hard drive. So this will create one in that location. So that'll be C:\VMs, and it's going to be called VM1.VHDX. Be 2 gig VHD. And to specify whether it's VHDX or VHD, it's right there. It's just in the file name that you give it. So now when we look at this, we'll see that it's the file size, that's 4 megabytes. So it's created a drive with a capacity 4 megabytes, a capacity of 2 gig, which is there, but the current file size is only 4 meg. It's a dynamic drive, and the rest is just general information. It gets a GUID, and yeah, 4K, as I mentioned, you get before. Now, this is all one line. I've just broken it up just to make it a bit easier for where we, I don't know where that E went. So when we want to create a VM, so we want to set its name, it's going to be called VM1 due to my lack of originality. We're going to give it the path to the drive that we just set up. It's going to have 1 gig of memory. It's going to use our test internal, which has been renamed to test private. It's going to be a generation 2 machine, and verbose is just going to give us that extra output. Okay, and there it is. So, as you can see, we've got this, it's powered off. We're not doing anything. It's got no assigned memory. We can do a get VM, VM1, and see the same sort of thing. Often it's uptime 0. Obviously, it's not powered on. And again, we go to Hyper-V management. There it is. So we can go start VM, VM1, and that's the same as running it. Now if we do get VM, we can see that it's using some more memory, how much processor it's using, uptime. So you can also use these get commands to give yourself a bit of a report if you don't feel like jumping into this, but you'll see, you can always see a big list. Fantastic. Now, stop VM, VM1. Yep, we want to stop it. I think the shutdown one, I've forgotten the shutdown command off the top of my head, that's okay. So, we've got a VM, we can start it, it's great, but maybe we need a bit more processor. So this is when we use set VM processor. So we're using it, we're going to set the VM processor against VM1, and the count will be 2. Done. We've now given it, if we go to settings, 2 virtual processors. Or if we wanted to set virtual memory, so we can come in and we'll see that the memory, here it is, we've set our dynamic memory. And then if we wanted to actually say take a checkpoint, we've got a checkpoint, which is all well and good. So doing it in individual steps isn't that quick, but say I wanted to have this VM, I could run that, and it's done. It's very quick to do it. If you wanted to roll out a few others, maybe I just might want to change the name, and off it goes. Or if I wanted to create quite a few VMs, we can run this. So this will create, off the top of my head, I think it's going to be 10 VMs, and hopefully I'm not going to get an error as we're likely to do. And I've just put in a couple of right hosts so we can see where it is, the names. And it's going to go through, it's going to create those drives, it's going to set the VMs up, they're all going to have the same settings, all be identical, and it means that if I had to do a lot, I'm not going to miss steps and everything else. Got it up to, there we go. We've got a heap of VMs. And I could start them, I can, if I did get VM, VM 1 star, I'll get VM, so I can see everything there that's got that. So if I wanted to start those, I could do start VM. I'm not going to because I may lock my lab up. I haven't given it a great deal of resources. But we could start them all up off that if we piped get VM through start VM. And again, if we don't stop VM, we can do that. Now, the last thing I wanted to touch on was the storage pools. Now, as I mentioned, storage pools, they give you a bit of flexibility in your storage. You can have them as failover clusters as well. So we'll wait for this to load up. Okay, so we can see storage pools from both of the servers because I managed it. We're going to do HV2 via PowerShell, but we'll do HV1 via the interface. So I've given these two 10 gig drives, and these themselves are actually from what's been presented as thin provisioned as well. Usually you don't want a thin provision. Test pool, not test pool, test pool. So what one do we want to do it on? So we'll do HV1. Now your primordial pool, that's where your unassigned disks sit. So we can select these. Media type, it'll either be SSD or hard disk. You can also have virtual disks in here as well, depending on how you want to do it. Because they're all the same, we're not going to do any clustering or anything fancy. So this will create our pool. Test pool, there we are. We have no more disks available, so we have no more primordial pool on HV1. We can add more disks as well if we choose to. So if we want to create a virtual disk, and we can present these virtual disks to our VMs, we can go test pool. So this is the pool we want to put the virtual disk against. Test virt disk, and we can't do tiering. And this is where we can set our resiliency settings. We'll keep these as simple, fixed or thin, just like a dynamic or a fixed disk. Same concept. We'll do thin, and I mentioned before about over provisioning. Let's make this 1 terabyte. You can see I've only got 18.5 gig capacity, 18 gig free space due to the overhead. I'm going to put a 1 terabyte drive on there. We don't want to create a volume on it. You can create the volume and do that if you want to. Now I want to present this to a VM, which means it needs to be an offline disk. We can't give this virtual disk to a VM while it's online. So we can see here the disk is online, even though we haven't formatted or given partitions, that sort of thing. And if I went into my VM and I wanted to add a hard disk, physical disk is grayed out. It's not available yet. So right click, offline, it's now offline. Settings, and we'll try that again. And now I can attach it. We're all good to go. I can boot that, it will use that drive, and we'll be good to go. I'm assuming I'll put an operating system on it. So what if I wanted to do it via a command? So against HV2, I can see which disks by using get physical disk, and I've just piped it through a where command to find where the status is can pull is true. So you can see I've got 2 healthy drives, 10 gig each, physical disk 1 and 2. So I could create a new storage pool, we'll call it storage pool 1, and for the physical disk where can pull is true. So if we went into HV1, because I have it here, I'm already managing it. Let's just have a look. We'll see that we should get a new storage pool. What do I call it? Storage pool 1. Look at that. And as you can see, that 1 terabyte drive has used another 2 gig of data. There's that little bit of overhead. Now, if I wanted to create a virtual disk, the command, very straightforward, is new virtual disk. And this is one of the things with PowerShell is the commands are very straightforward. It's what you want to do to what. So I want to get physical disks or new storage pool. The main thing that, or if I want to make a change, is usually set. Remove is usually remove. The main thing that trips me up these days is mainly sometimes you want to know, you're not sure if it's going to be a add command, like what we've got down the side here. We've got a lot of add commands, but then we can go down and we have a lot of new commands. So sometimes just working out whether you want to add or new, you normally just find it out through good old Google. Now, if I want to create a virtual disk, we can create a virtual disk and we're done. So that's created a virtual disk. Once we refresh again, and there we go. It's a fixed size. The mirroring's there. It's only got a gig allocated. And there we go. So as it's fixed, we can see that it's actually used a bit more space because it's a mirrored disk. So just one thing to keep in mind, that's actually used, what do we start at, 18, about 4.5 gigs. So we've got half a gig overhead, and then it's mirrored on both those. So it can take up a bit of space when you're using fixed. So, and just like dynamic versus fixed on your VHDX files, you do get a little bit better performance out of a fixed virtual disk. So that covers everything I wanted to show. And like I said, I'm just trying to give you a bit of a overview in Hyper-V, a bit of a few ideas to have a look around at, have a poke, and see what you like, and hopefully help get you ready for our certification course. So if you've got any questions, any queries, comments, I'm on Twitter at BrettJohnson008, and this has been another podcast for vBrownBag APAC. Thank you for joining me.